Hello students of AHR-160. I'm here for another lecture video to tell you the difference between two of these metering devices that you see on the screen. Now obviously a metering device, that's the opposite of the compressor. It's the part that does the depressurization of the refrigerant as the refrigerant's traveling into the evaporator. But I'm just going to point out some features of these and then we'll go on about our day. This metering device up top is called an actuator piston. And what it is a very precisely machined piece of brass. If we could actually turn it to see the front of it, we'd see that there's a hole going through the center of it. And that's the hole that is sized at 59 thousandths of an inch. As you can see, that 0.59 on the side of the body. This thing can move back and forth, in and out of check, depending on whether it's in a heat pump or not. A heat pump has to turn the refrigerant around and make it flow the opposite direction, so it just moves back and forth. Forward to let the refrigerant through the center of it, backward to let the refrigerant flow around it so that it doesn't actually meter the refrigerant in that direction. Now the one on the bottom here is called a thermostatic expansion valve, and this is probably the most common metering device in the industry right now, especially in air conditioning. And it's really popular because it can maintain a constant superheat and adapt to changing load conditions where the traditional fixed bore actuator piston cannot. What you're not seeing on this TXV here is the remote feeler bulb, and what it's going to do is actually be a temperature sensor for the valve. So there is a pressure inside of this bulb, and that bulb is attached to the suction line. So this is your suction line that's leaving your evaporator and going back to your compressor. Now as the temperature of that line increases, so is the pressure in this bulb. The pressure in this bulb is going to transmit that temperature as a mechanical pressure into this valve so that we can work with it. So basically it's taking the temperature of the line, it's reporting it back to the valve mechanically. The valve is going to calculate mechanically the superheat. Whereas you calculate the superheat of the system on pen and paper or with your gauges or something like that as a service technician, it's actually doing it mechanically. We've got liquid coming into the TXV, gas coming out, or I think I'm on the wrong end. So the liquid's coming in this side, gas is coming out of this side. And there's a third port here. And you might be wondering what that's for. That's actually to get the pressure that's within the suction line back to the valve, because that's important too. The pressure in here and the pressure in here are different pressures, and we have to balance those pressures in order to get the proper flow rate through the valve. So a lot going on there with the TXV. Just the important thing, the important takeaway is that it maintains a constant superheat in the system and adapts to changing load conditions where fixed bore metering devices cannot do that. And that's the main takeaway. So hopefully you learned something from this video. Hope you enjoyed this video, and I'll see you in the next one.